Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Easy Learn, and today's video is another episode number 28, and from today's episode we had decided one important thing. From today's video onward, we will not try to increase video length to above 20 minutes. This is the threshold value. If for example my video goes to 21 minutes, even 1 minute above 20, then we will cut this video and add it to the next episode. So this is what we had decided, because you know, from the last couple of episodes the quality of the videos, audio and everything is improved, and because of that it is quite difficult for me and for my other brothers to upload and render the project, and so that because of the size is increased, bit rate is very high of these videos, so all of this, that is the one thing that we had decided. So it is very short time for me right now, so and without wasting any time, let's start and continue today's lecture. The title of today's lecture belongs to a new topic that is started from episode number 28, that we are now we had now learned enough that to write and prepared to write the sets of equation from now on. Now we are going to practice writing the equations. From now onwards we are ready to practice the how to write the equations. First of all, let me tell you one thing, that these are the some basic steps that we will try to follow in the all lectures from this lecture onward, because from this the writing equation actually need a lot of practice. We cannot write the equation without practice. For this reason we had decided to practice a lot of with the help of examples. Sample networks will be chosen and used in this series. So I had decided very basic series RLC network that will be the part of today's lecture. We will try to focus on it and write its equation, basic RLC network, and for this reason I will decide first some rules that will be adopted from the coming lectures. Okay, so these rules are first of all written here. We understand that we may make use of the node method or the loop method or any other method in writing the equation. So there are the 2 or 3 methods. First of all, we learned method number 1 is we can choose either loop method, that is called here KCL, means loop method. I'm sorry, Kirchoff voltage law. Loop method is the voltage law. For example, this is our resistance, this is resistance, and here we have a voltage source. Maybe this is our rest of network. So this is all belongs to Kirchoff's voltage law. And in voltage law, this is a closed loop and this is a closed loop. Loop is actually a closed path. This is actually a wrong term, closed loop, which I am using right now for giving you some understanding, but loop is itself is a closed path. We don't need to say closed loop. Loop is a closed path. This is a loop. If we are going to start from a point and end at the same point, this is called a loop. If this is a path of the current and after passing, but this is not coming to this point and this is an open circuit, this is not a loop. For example, if there is nothing connected here and it is an open way, so this is not a loop. So okay, so this is first of all we can apply the loop method using KVL. Second is we can apply the node method, which is the KCL, definitely, or any other method that will be discussed later on can be applied here. But there are some precautions and some basic basic requirements that need to be followed. First of all, then we will decide what choice we have to make in terms of such factors. So what are the factors? Number 1 factor is which method results in the smallest number of variables. We will choose the method. These are the actually methods. MET, HOD. Anyway, these are the 2 methods I written here. We will choose the method which belongs to which results in the less number of variables. For example, the first method I choose, Kirchoff's voltage law, results in V1 minus V2 is equals to Vi IR and so on. You can see there are one voltage, second voltage, third current, and 3 variables can be seen. While on the other hand, if we apply the Kirchoff node law, current law, if apply the Kirchoff current law, we can see I is equals to V over R1. So this is a simple, then we will choose definitely this one as compared to this. Why? Because it results in smallest number of variables. As you can see here, the current is our first variable, voltage is another variable, but resistance does not belong to variables, because resistance will definitely has a particular and specific value. We don't need to we will not consider it in variable. It has a constant value, while here 3 variables. So the choice will be definitely selected depending upon the having the less number of variables. So what is the second point of the selection we will choose is the objective of the analysis. I mean, for example, we are choosing this method or this method, but second is, what is the objective? If our objective is to obtain V2, but here V2 is not seen, we cannot see the V2 in this equation. So we will have to switch to this method because we have no other way. Unfortunately, we have to select this method because our second point tells us we have to be very conscious about our analysis. For example, if we choose, if we look at the first point, less number of variable, definitely this will be our choice. But the second point tells us what is the objective of analysis. If we are not focusing on our second point, we start this way to solve for the current, and we don't need current. Then what happens? Ultimately, our answer is useless. We cannot use it. This is not desired, and our marks will be definitely 0 in the exams. So this is the best way that you also have to consider that what is the required thing, what is the objective, how many currents do you need to calculate, how many voltages do you need, either one voltage or current. Then we will definitely select our analysis. So what is the third option? Third option is very, very interesting, that we have to understand that we have to solve method of solving. What is our method of solving? Either we are solving by the hand method or by using the digital means computers, involvement of the computer, MATLAB and these type of software. And if we have a digital type of solving method, MATLAB for example, then we definitely not consider about worrying about different variables. We will go through the process. We are not worried about these things definitely, because computer can solve all the million of processes and integrations within seconds. So but the hand method, paper method, like we are trying right now, this is a hand method by ourselves, man method. So this is definitely a difficult method, and we always have to be worried about, and when we choose this method in exams, we will always select the small number of variables, unknown variable, because if we increase the variables, it will result in what is the result? It will results in increase of the simultaneous equations. It will result if we increase our unknown variable from 1 plus 1 plus 1 3 to 4, our even if one variable is increased, our simultaneous equations are going to be increased by 1 also, and this one going increase results in very, very high method will be increased very high, with very high rate. So this is the thing we need to also consider. Moving back towards our first example, this is the pink color actually in today's lecture indicates very important discussion that we are going to follow from all the lectures, next coming lectures. And now moving back toward our main example that we are going to follow in today's lecture. From the next and coming lectures, we will try to discuss some difficult examples also, but in today's lecture we had selected some very basic example, that is if series RL, first of all resistance R, then L. This is not actually a law that you have to write down first R, then L, and then C. This is just for understanding R, L, C network. And you can see, first of all, either this is a series or a parallel. This is definitely a series because there is only one way of the current to flow through, and this is the direction of the current, that is the current. We have to write it I of t, which shows that the current is definitely depending on the time t because it is time varying current source. So if we consider for the voltage that this is the voltage, it is also V of t, which means that the voltage is also time varying. When we consider these time varying sources, current or voltage, we have to write I and V in small letters with small alphabets. So this is the conventionally current direction of the loop, that the current is flowing in clockwise pattern. So first of all, how we can write the equations. First step is to apply the Kirchoff voltage law here. This is what I told you, apply the Kirchoff voltage law. In case you are not supposed to and in question you are not asked to what you have to find out, what you have to do. Here I told you apply KVL and find the network equations. So this is the question actually. So I am just applying the Kirchoff's voltage law and going to calculate the number of equations, finding the number of equations. And in case if you are asked to apply the Kirchoff's current law, then this is a different scenario and we will be discussed in the coming lectures also. So without wasting any time, let's apply the Kirchoff's voltage law. Let me tell you one thing, that the Kirchoff voltage law, Kirchoff current law are explained in earlier episodes, so I'm not going to try to explain again and again. So this will definitely create an additional, this will definitely take an external and additional time, so which we don't have right now. So V of t, which is our voltage from the sources, is equals to all the consuming elements. Here this is the active element. Active elements must be equals to all the passive elements. So voltage of active element, there is only one active element. So V of t is equals to voltage consumed by three elements. So three passive elements are written here, active elements are written on one side. So this is the rule of KVL, and a closed loop must be there. A closed loop, which is a first requirement. Second requirement is there must be an active. Actually Kirchoff voltage law tells us that the summation of all the voltages inside a closed loop must be equals to 0, which is true. Actually this is a source and all the three passive elements will consume these voltages. There is nothing else extra which we can see or hidden. So but here the first voltage, that is the across R, so that is consumed by a resistor R. The second voltage here you can see is consumed by L inductor, and the third voltage that is consumed by the capacitor. So let me tell you one thing, that there are different formulas for different type of passive elements. Different formula for resistor, different formula for inductor, and different for capacitor. This is our first chapter number 1. This is chapter number 3. If you are a new student, joined later and you haven't watched our earlier episode, go back and watch the earlier episode. I don't remember actually the episode number, but I think maybe up to episode number 10 or so on. You go back and I think title is there, you can easily search out. Anyway, so for again repeating, for resistor, very basic, we use all time resistors. So I don't think that you need to look back through your notebooks, because we used resistor many times in our series. So for resistor, voltage formula is IR. So just apply I, small I, and R. R is constant, so don't need to choose anything. Next is voltage of inductor. So for what is the formula for inductor? Formula for inductor, V is equals to, what is the formula for inductor? L di, derivation of current with respect to time t. These formulas are derived also earlier. How these formulas come and why we choose this? This is a very, very important table that we discussed in the earlier episode. So go back, and I recommend you, if you haven't, so this is very, very important. You have to stick the paper, write down on the front pages of your notebooks So because this is the first thing while opening the notebook for the network analysis, you always look, your eyesight must go there and recap each time while opening book for the network analysis. So what is the formula for the inductor? Here we have the L, not specified as a L1 or L2 in our RLC circuit. So simple L, di, derivation of current, there is only one current, so di over dt. Here why we left the L? Because L has a specific value. For example, L has a value of 10 Henry, so we will not going to choose take the derivation of a constant value. If you know about if you have a how know about mathematics, this is simple mathematics. Plus, what is the voltage across capacitor? So in case we have a capacitor, for the voltage across capacitor we have a different 1 over C integration I dt, means integration with respect to time t. So this is the integration. Now in the previous case we have derivation, but now we have integration 1 over C. We have left the capacitor because also capacitor is a constant. C has a definitely have a capacitance is a constant, for example 5 microfarad. So it is, we are not going to consider it. So 1 over C integral, it is beyond, it is exempt from the integration I dt. As you can see, this equation, this is the required equation what we are looking for, but sometimes to solve this equation, but this is not our task to solve right now. We are just beginning we are just in the start of how to write the equations, how to set up the equations. So this is our first step. This type of equations is called integro, very difficult term, integro differential equations. Means this is integration and differential, both are includes. So if both are involved, we call this type of equation integro differential equation, which is really difficult to solve. We can convert integro differential equation either into differential equation only or into integration equations only. The best way to do so is I want to convert this into differential equation. If we take the differential of the integration, for example integration, the answer is results in cancellation and the differential will be gone. So I want to remove this integration from this entire equation, and what I have to do is take the derivation of this equation. To take the derivation of this equation, very simple, d over dt of this voltage. Okay, v of t it is understood, so that's why I am just writing dv. So derivation with respect to time, then derivation of this d over dt of current, not resistance, because resistance it has a constant value. As I told you, inductor has a constant value. That is why we are not taking this resistance inductor into the differential sign. So constant are taken outside from the differential jurisdiction. So L, here we have already derivation, no problems. Derivation will be going to double derivation, dt square. Derivation is increased by 1. We have to now double take the derivation of the current. So here you can see that differential and integration are going to be cancelled out, and what we left is 1 over C multiplied by I. So this is the end of today's lecture, and this type of equation is called differential equation. And we can also convert this integral differential equation into integration equation, but it is easier to solve differential equations. That is why I converted into this. We can also, if take the integration of this whole equation, then at one point this will be cancelled out. The whole equation can be converted into integral equation. But you know, the time has been time is very short. Time is already full, so we have to stop here. Inshallah, next time we will continue the another example. So take care. Allah Hafiz.